So firstly, let's say we have an equation y equals to x raised to power n. Okay.
Yeah.
So the first derivative of this would be the power becomes the coefficient of the term. Then you subtract 1 from the power. That's how you differentiate, basic differentiation. If y equals to a constant, the differentiation of this is 0. Why? Because whenever there's like constant, if there is a variable with it, that variable has a power of 0, right? Because anything to the power of 0 is 1.
Yeah.
So if you derivate this, wouldn't this be like 0 times the constant x to the power of 0 minus 1? So everything gets multiplied with a 0. So it ultimately becomes a 0.
0. Yeah.
Exactly. So that's why the derivative of a constant is 0. And if you have two functions being added, let's say f of x plus g of x, that equals to y. Now dy by dx of this is the derivative of the first function plus the derivative of the second function. The same goes for if two functions are being subtracted. You just subtract the derivatives. Any questions so far?
No.
So now let's say we have an equation y equals to 4x cubed minus 1 over 2 x to the power of negative 1. Okay?
Yeah.
Now, how would you differentiate this?
Do you do 3 3 into 4? 12.
Yeah. What about the power?
12x. You minus it by 1, so it's 2.
Correct. And what about the second term?
The second one, you do 1 by 3 into x minus. I don't know.
It's okay. Don't need to panic. 1 by 2 times negative 1, same thing as before. X to the power of negative 1 minus 1. Okay?
I didn't understand. I didn't understand the last part.
Okay, so look, whenever we're differentiating, we subtract 1 from the power, right?
Yeah.
So since the power of x in the second term is negative 1, so won't we do negative 1 minus 1?
Yeah, okay. Yeah, got it.
Same thing as before. So this becomes 12x squared plus 1 by 2 x to the power of negative 2. Any question?
No.
You could rewrite this as 12x squared plus 1 over 2 x squared, and that's it. That's your answer for the first differential.
Oh, okay. Thank you.
Now, if they ask you to find, let's say this was the first part, find the first derivative. Now they're asking find the second derivative. In this case, what we do is we are differentiating the first derivative again. So the first derivative is this 12x squared plus 1 over 2, 1 over 2x squared. How would you differentiate this again?
Wait, I didn't understand. I didn't get that.
If they ask you, this was y, right? Equation y
Yeah.
equals to 4x cubed minus 1 over 2 x minus 1. Okay? When we differentiated it once, we got 12x squared plus 1 over 2 x to the power of negative 2, correct?
Yeah.
Now they're asking you to differentiate it again. How would you do that?
Do you do it again? Do you do the same thing? 12 into 2
Yeah,
minus 1?
yeah, it's the same thing. You just repeat the steps again. So
Yeah.
12 times 2, x to the power of 2 minus 1, plus 1 over 2 times negative 2 times x to the power of negative 2 minus 1.
Yeah.
Any question?
No. Can I just write that down 1 second?
Yeah,
Okay, I wrote it down. Thank you.
sure. So your answer can be rewritten as 4x minus 1 over x cubed. So we've covered the first derivative part, we've covered the second derivative part. Any question from all of this?
No.
Now, next thing they can say, find the equation of the tangent to the curve at, let's say, point P, which is 2, 1. Okay.
Yeah.
So, what do you think we will do with this?
I have no idea about this one, like
Okay.
at all.
Okay. So we have an equation of the line initially, which was 4x cubed minus 4x cubed minus 1 over 2x to the power of negative 1. We found the first derivative, which is 12x squared plus 1 over 2x to the power of negative 2. Now, do you remember coordinate geometry?
What? I
Coordinate
can't hear
geometry.
you.
Can you hear me now?
Yeah. Yeah, I can. Yeah,
Okay, so
I'm
I was,
familiar with it.
yeah, so how do we find the line of an equation in coordinate geometry?
Um, was it y equals mx plus c? I'm not sure.
Okay, yeah,
That
that's
was the
right.
gradient.
Y equals to mx plus c is for the line of equation.
Yeah.
Okay, so they want us to find the equation of the tangent, which is also a line, right?
Yeah.
So in y equals to mx plus c, what like terms do we need to have an equation like this?
The gradient, the
Hmm.
y-intercept, and
That's it?
yeah,
Okay.
I
So
think.
how do we find the line of equation for the tangent to this curve?
Um,
You just told me the things that we need. So how can we find those things to find the line of equation?
that's I don't know.
Okay, look. We found the gradient, the equation for the gradient, right? Which is this.
Yeah.
This is your gradient. They already told us in the question that the curve is tangent to the curve at point 2, 1.
Yeah.
So can't we use this point to find the value for the gradient?
Wait, I'm a little confused. I
About
don't
what?
understand. Yeah.
Which part is confusing here?
Um, I don't understand the whole thing about finding the equation of the tangent. Like, I
Okay,
don't
so
know. Does it make
it's okay, it's okay. Let me just draw a rough diagram of, let's say, this is our curve, okay?
Yeah.
And this is the tangent is at this point, supposedly, okay?
Yeah.
This is your point P. Now, if you have the equation of the curve, okay, you have the point at which the tangent is touching the curve, which is point P, correct?
Yeah.
And you yourself told me that we need the gradient and the y-intercept for the equation, right?
Yeah.
So if we have the equation of the gradient of the curve, isn't the equation of the curve and the gradient of the curve and the gradient of the tangent equal?
Wait, I didn't understand that. Could you repeat it?
Gradient of the curve is always equal to the gradient of the tangent.
Yeah.
Okay? So if we have the equation of the gradient of the curve, can't we use that equation and the point at which the tangent touches the curve, find the value of the gradient?
Yeah, we can.
Exactly. So what we do is we just substitute the value of x in the dy by dx equation. So 12 times 2 square plus 1 over 2 to the power of negative 2. Okay?
Yeah.
48 plus 1 over 8. Can you tell me the answer to that?
Um, Wait 1 sec. I
You
can't
have
do.
it?
Let me just get my calculator.
Okay. Wait 1 second. I'll wait.
Is it 48.125?
Hmm. Okay. So this is a gradient of the curve and the tangent, correct?
Yeah.
Right. Tangent. So now next thing is finding the, wait, we have the 0.21, we have the gradient. We can use this equation, line of equation from y minus y1 equals to m times x minus x1. Are you familiar with this?
No.
No? Okay, then I'll just use the y equals to mx. So for y equals to mx plus c, what we'll do is we have a point, we have the gradient, but we need the y-intercept, correct?
Mm.
So you
Yes.
substitute these values. Y is 1, m is 48.125, x is 2 plus c. So now 1 minus 48.125 times 2 is
It's 96.
96.25, yeah. Then 1 minus 96.25 equals to c, which is minus 95.25, right?
Yeah.
Okay. Now we put these values in the equation. M is 48.125, x minus 95.25. This is your equation of the tangent. Any confusion about this now?
No.
Sure?
No.
Okay. Now if they were asking you to find equation of the normal at the same point.
Equation of the norm.
Yeah, this is the normal at this point. So now how can we find the equation of the normal?
No clue. I don't know.
Okay, so once again back to coordinate geometry. If you have a line that's perpendicular, if you have two parallel lines What's the gradient like? What's common between the gradient of these two lines?
Wait, I didn't understand that.
If you have two parallel lines, this is AB, this is ED. What's common
Yeah.
between the gradient of these two lines?
Um, I don't know.
Gradient is the
The
same, M1 equals to M2. Okay? And if two lines are
yeah.
perpendicular, AB is perpendicular to CD, M1 times M2 equals to -1. These are the
Yeah.
two conditions for gradient in quadratic geometry. Okay? This is for
Yeah.
parallel, this is for perpendicular. So normal is something that is perpendicular to a line, right?
Yeah.
So what we'll do is, since we have the gradient of the tangent, which is M1 is 48.125. M2 is the gradient of the normal that we need to find. So you will use this formula, M1 times M2 equals to -1. Okay?
Yeah.
48.125 times M2 equals to -1. M2 equals to -1 over 48.125, which will equal to
Wait, I don't understand
what, sorry?
why we I don't understand why we use the formula.
The formula is basically a condition in coordinate geometry. When two lines are perpendicular, the gradient
Yeah.
of one, the product of the gradients of both the lines would equal to -1.
Oh, okay.
Okay? So we just use that when we know that two lines are perpendicular. If we know two lines are parallel, then we know that the gradient of them is same.
Yeah.
Okay? So we use that. Now we have the gradient, which is -0.0207. Once again, they gave the point of the question, which is 2, 1. So you repeat the steps. Y equals to mx plus c. 1 equals to -0.007 times 2 plus c times 2 is 0.0415. 1.0415 equals to c. So your equation to the normal is -0.0207 x plus 1.0415.
Yeah. I got it.
Sure?
Yeah.
Okay, so last thing they can ask you is about the stationary points. Okay,
Yeah.
so 1 second. Do you remember the equation of the first derivative?
Yeah. dy over dx. Yeah.
Yeah, okay. So can you tell me the equation?
dy over dx
Equals to what?
equals this thing 4x cube
Hmm. No,
minus
wait.
half x 1
That
by
was the
2x.
equation for
Oh wait.
y.
Yeah. Sorry. 12x square
Hmm.
plus 1 by 2 x minus 2.
Okay. So now, whenever they ask us to find the stationary points exist at the point where your dy by dx is 0, which is the turning point.
Yeah.
So what we do is we equate the dy by dx equation to 0. So that's 12x squared plus 1 by 2 x to the power of negative 2 and 24 x squared plus x power of negative 2 here equals to 24 x to the power of 4 plus 1. So since I assume the value, so it's going to be a weird number, but like technically speaking, these are going to be your steps.
Yeah.
Okay. So this way you
Yeah.
get your stationary points. Once you have a coordinate of x, you plug it back into the equation of the curve, which will give you the value of the y coordinate.
Okay.
Any question?
No.
Sure.
Yeah, yeah. Sure. Oh, we put this back into the first equation, yeah?
Yeah, the first equation.
The y equals, is it that
Yeah,
one?
yeah. That's the y coordinate. So I think we've covered everything in differentiation then.
Yeah.
Is there anything else that we've done so far?
No, I think this is all we did.
What is it? Okay, okay.